I have no idea why it doesn't record. But it says recording, but
Yes, sir. It's, I think, I don't know.
it should be recording, but I don't know. I've clicked the recording, but because these people have removed my, my net has been taken off, so I'm doing it by some other net method. So anyway, can you see the
Yes, sir.
whiteboard?
Yes, sir.
So now let us do some simple problems. Let us start with the simplest and begin with Michaelis-Menten. You have Michaelis-Menten kinetics. You remember your V by S?
Yes, sir.
And you remember this graph, right? Now, obviously, because substrate is declining, I mean, I can ask more complex questions, but I'm not. But let us not. For example, when we actually look at the product formation rates, P versus T, then you can get a graph like this, and then it will decline. Now, notice that this decline, this P, the derivative dP by dt is a constant at till this point. The dP by dt is essentially a constant, and dP by dt is obviously equal to V, right? And then this derivative tends to sort of, this derivative, this is the tangent to the slope, it tends to decline. Now, the argument here is that if this is the substrate concentration and this is the substrate concentration here, this is the substrate concentration here, and then at some point the substrate concentration is here and this is the substrate concentration here, and then at some point the substrate concentration is here and it is here, and obviously as the substrate concentration tends to fall, the dP by dt tends to fall. That is the basic argument. But this is not necessarily true. This is the simplest case. Now, dP by dt may be falling because the substrate concentration is, with time, this is how it is going. And that is why this slope is sort of tending to decline. But this could be declining well because of, say, product inhibition also. Or it need not be due to substrate starvation, which is what we are pointing out, substrate starvation. And therefore, from first order, it has moved to from zeroth order, it has, this is the zeroth order reaction rates, zero order reaction rates to first order, and that is why this is declining. But it could well be because of product inhibition. It could well be because of enzyme deactivation. Now, how do you find out, or what experiments would you perform to find out whether this decline in product formation rate, the fact that this does not keep on going up straight like this decline that you see is because of substrate starvation, product inhibition, or enzyme deactivation? What kind of experiments would you perform to determine what is happening? For example, and obviously the logical answer is that we start with different substrate concentrations, starting S0s, S01, S02, and so on and so forth. And we get graphs like this. Or we may get graphs like this. Now, what does this graph tell me? What does this graph tell me? Basic, very basic concepts, but to be applied. Very simple equation, V versus S. What does this graph tell me? What does this graph tell me? About substrate starvation, product inhibition, enzyme deactivation.
Sir, it's in first.
What about this one? Yeah. So here the reaction rates are changing.
With diffusion.
As we have. So very clearly, but they are all reaching saturation after some time. After some time, the dP by dt is going to 0. Here, so at a certain time, after a certain time, the dP by dt is going to 0. The velocities, this is P. Notice, and this is P versus T, and this is V versus S. Notice that they're completely different graphs. So I want you to think about it and decide What is this happening here? Here, the velocities go to 0 at different p-values. They don't go to 0 here. For example, I could have another situation here where I could have this is P versus T. This is another graph. So now notice these are different graphs and all of them have different kinds of profiles. And so you can see that they are tending to 0. So now notice that here, for example, at a certain p-value, they are tending to 0. Obviously, you will not get a graph, such a wonderful graph like this, but this is for conceptually understanding or qualitatively understanding what is happening. If they're all going to 0 not at a certain, they're going to 0 at different times. Obviously, this is at a S0 I1, which is higher than this S0 2, which is higher than this S0 3. This is greater than this is greater than this. Obviously, that's why initial rates are different. But at a certain P, they all tend to 0. So most probably, this is the kind of situation which is possible to product inhibition. But here, they go to 0, not at different P values, but at the same time. So quite possible that enzyme deactivation is responsible. And I'm giving you the crude first order approximations. You see the argument? So you have to be able to distinguish between various situations depending on the patterns of the graphs that you see, which is not just solving solution. Now, for example, let me ask. So obviously, taking a slope here or a tangent here, when your data points are very, very badly distributed here, is a very poor idea. So now let us sort of say that we can use this and plot velocities, and we can try to look at tangents and look at this graph. Right? Now, the question really is that this graph is a tricky business to find out Vmax and Km. And taking slopes here is even more difficult because that's the second order derivative. Right? So, yes, so let me ask you, what would happen? These are the questions that are sort of, okay, let us ask some more interesting questions. Let us ask, these are the questions that I would like you to be able to think about as part of your entrance, as part of your abilities to understand the subject better. Let us ask another question. Suppose we have this graph here and I draw tangents. Oh, sorry. Instead of drawing tangents, I draw curves. I draw tangents and I draw curves, which pass through this graph at these points. And this is my asymptote. What are these points? So for example, what would be this point when I draw a tangent at the original value of V versus this? What would be this point if I draw this straight line which cuts at V by 2? What would be this line and where would this point be if it cuts at 2 by 3V or 3 by 4V? Or let us take an even more interest, or let me reverse this question. And these are the questions that I'm going to ask one after the other, because I can't, I mean, I just want you to think and go back and look at this lecture and actually solve these problems. For example, if I say that I draw a asymptotic line, which is possibly Vmax, right? This asymptotic line is Vmax. I hope you realize this.
Yes, sir.
Right? This line is Vmax. Now this is Vmax. This is S. This is V. Now I draw a line from here to here, and let us say it cuts at Km. Where will it intercept this line? And it cuts at 2 km. Where would it intercept this line? Suppose it says it cuts at 3 km. Where would it intercept the line? So the question that I'm asking you is that this is my line. This is my asymptote. And I draw a line like this. And this is say 3 km. I don't know it is 3 km, but I know that at this point, what is this point? Tell me what is this point, and then we will do the reverse. We will reverse this problem and say, well, let it cut at V is equal to V max by 2 by 3 V max, or V max by 2, or 3 by 4 V max, and so on and so forth. And so let us do this. When does it cut at Km? Or when does it, let us find out when does it cut at Km. A line which cuts at Km what is this line? What is the basic equation? V is equal to V max S upon Km plus S. So I want you to be able to handle this. Now what is the tangent to the slope at S equal to 0? What is dV by ds? Oh no. Sorry. These are the kind of questions, conceptual questions that I want you to answer. What is dV by ds at S equal to 0? Or S tending to 0? As S tends to 0, what is the dV by ds? It is approximately equal to Vm by Km into S. So the slope would be, so this is Vm by Km.
Vm by Km.
And a line y is equal to mx, that is V is equal to, this is the line, the tangent to the slope, V is equal to Vm by Km into S, right? Passing through the origin, this is y is equal to mx. There is no plus c here, it's all passing through the origin. And the slope is Vm by Km. Then what is the, where would this line intercept the line V is equal to Vm? What would be the S value? This is the straight line, V is equal to Vm. This is the asymptote, isn't it?
Yes,
this is x is equal to a constant. So it would intercept at Km. Can you see that?
Yes, sir.
Right. So the tangent to this line, the tangent to this graph here, this tangent, this tangent here, intercepts at Km. Correct?
Yes.
So the tangent intersects at Km. What intercepts at 2 Km? What line would intercept at 2 Km? Where would this? Now you have the line V is equal to Vm, and now you have this equation here. Right? Can you see this equation here?
Yes, sir.
Now I want to draw a line which cuts this line and intercepts at V is equal to 2 Km. Can you tell me how we will handle this? This is simple algebra again. But you know, I am very scared that you people have, as I said, JEE exam over and then you have forgotten everything. So now I want you to find out the equation of this line. This line. So it cuts at 3 km. Let us say 2 km. Let us do 2 km first. It cuts at 2 km and it passes through 0. So what is the slope of this line?
Yes, sir.
Vm by 2 km. I hope you realize this, right?
Sir, Vm by 2 km.
The slope of this line, slope is Vm by
2 km.
2 km or 3 km or whatever, right? Wherever you wanted to cut it. That is how it will cut this at this line, right? Because this is the y-axis Vm, and this is the, you want to look at the asymptote. So your equation is y is equal to mx. So you have v is equal to Vm by 2 km into s. Is the equation of this line?
Yes,
Correct?
sir.
Now, and this is the equation. Sorry again. So now these are the two equations. This is 1, this is 2. So where do they cut each other? They both pass through 0, so obviously they will cut at 0. But what is the other point that they will cut? You have to put them as equals. ये क्या आ गया? Now tell me.
1 second.
हाँ, do करिए आप इसको. Solve for S.
Sir, km by 2 km minus 1.
नहीं देखिए भाई, ये Vm by 2 km है, ये 2 km है, तो S is equal to km हो गया ना. भाई ये इक्वेशन क्या है? ये इक्वेशन है V is equal to Vm upon km plus S into S.
Yes,
और
sir.
ये इक्वेशन है V is equal to Vm upon 2 km
kms.
into S. भाई इतना कॉम्प्लिकेटेड क्यों कर रहे हैं आप इसको? तो क्लियरली S is equal to km.
Yeah, yes.
ठीक है ना? If S is equal to km, V is equal to Vmax by 2. ठीक है ना?
Yes, sir.
क्योंकि when S is equal to km, V is equal to Vmax by 2. है कि नहीं?
Yes, sir.
तो फिर आपका क्या हुआ ये? मतलब भाई ये आपका, तो फिर आपका जो प्लॉट है, ये प्लॉट जो है आपका, ये आपका प्लॉट है ना, आपका ये प्लॉट है, ये लाइन, ये Vmax by 2 है, ये एसिम्पटोट है. तो आपका जो ये लाइन है, ये वाला जो लाइन है, ये आपका कट कर रहा था km पे. ओह, ये यहाँ पे आपको km पे कट कर रहा था. ठीक है? इज इट ऑल राइट? कैन यू फॉलो हिंदी और शुड आई टॉक इन इंग्लिश अलोन? इज इट बेटर? व्हाट लैंग्वेज यू प्रेफर?
Sorry,
But when anything is fine. So now this is V by 2 and this is S equal to km.
yes, sir.
Right. So if I draw a line like this from here to here, this will be 2 km. ठीक है कि नहीं?
Yes, sir.
The tangent will cut at km. The line passing through V by 2 and through 0 will cut at 2 km. And what will be at 3 km? Make this as 3 km here. Can you see this? So very clearly S is equal to 2 km.
Yes, sir.
ठीक है?
Yes, sir.
And if S is equal to 2 km, then V is equal to Vmax 2 km upon km plus 2 km, which is 2 by 3 Vmax. So अगर आप ये 2/3 पे चले जाते हैं और एक टैंजेंट खींचते हैं 2/3 से कट करता हुआ, ये 2/3 है, तो ये 3 km हो जाएगा.
Yes, sir.
और अगर इसको 4 km में कट करना चाहते हैं तो आपको 3/4 पे पास कराना पड़ेगा. So now you realize this line passing through Vm by 2 will cut at 2 km. The line passing through 2 by 3 Vmax will cut at 3 km. The line passing through 3 by 4 km will cut at 4 km, and so on and so forth.
Yes, sir.
So instead of trying to draw tangents, it makes much more sense to take the original point, look at 2/3 the velocity or 3/4 the velocity, and draw a secant line. Draw a secant rather than a tangent. And secant is much more easy to draw graphically. Correct? If you have a V versus S plot, which is approximate and it is error prone, then you draw this line approximately through this and then draw a secant and see where it is cutting the asymptote, and that is your 2 km or 3 km or 4 km. And that allows you a much accurate determination, graphical determination of km and a graphical determination of Vmax without going through the error associated with a double reciprocal plot. Are you following this argument?
Yes, sir.
So we can think of clever methods to actually get rid of this whole problem of error. can get rid of error by these very simple techniques of drawing secants rather than tangents. Tangents means derivative. Derivative with an error-prone plot is a problem. But if we can draw a smooth curve of V versus S of the form this is the form which is a typical plot which you can fit using your standard saturation kinetics model. This is saturation kinetics, isn't it? So first order and then 0th order saturation kinetics, and then instead of trying to draw tangents all over again, because this is anyway dp by dt and this is a tangent plot, taking second derivative with error prone data is a problem. We can draw secants, and from the point that it cuts the asymptote we can find out km values, and we can draw tangents, and we can draw secants through 2 by 3, we can draw through 3 by 4, and thereby we can determine the slope, and from the slope and the intercept at this point we can find out Vmax and Km. Are you getting this? So these will be some interesting problems to solve even with very simple elementary equations of the form V is equal to Vmax S upon Km plus S. Can you now, suppose I give you data P versus T, can you find out dP by dt approximately and then plot this graph and then draw secants and find out how Km is determined, and maybe this will be a better estimate. Are you following this argument?
Yes, sir.
Yeah. Now let us do some more such exercises. And all of these require mathematics. Can I rub this out? So this is one example of ways to do it. For example, now you will say that, and we should say that, well, hold on, even dP by dt is very difficult to measure, because as I said, the P versus T graph goes like this. So at a certain start S0. So obviously the logical thing is to sort of say that I will draw a tangent like this and find out dP by dt at t is equal to 0. And then, I know that this is the velocity V, this is V at S is equal to S0. But S is declining immediately. Notice that it has started falling immediately, especially when you are doing experiments and you are choosing substrate concentrations at this point. If this is your starting substrate concentration, say actual experiment, this is the plot that you have to generate, but this is your starting S0. Immediately within a few minutes, it has gone here. So where have you measured? Have you measured this or have you measured this? Because this is what this here, this value V here is the actual tangent, but this value here is the value V of this slope here, and so you are into trouble. So suppose now I say, भाई साहब ये तो बहुत मुश्किल काम है क्योंकि मेरे पास तो टेबल है, and that is what I give you. T is equal to 0, P is equal to 0, T is equal to 10 seconds, P is equal to 1, T is equal to 20 seconds, P is equal to 1.8. तो देखिए एक सेकंड में 10 हुआ और अगले सेकंड में 0.8 बढ़ा, और ये 30 है तो ये 2.4 है, 40 है तो ये 2.9 है, something like this. मतलब मुझे नहीं मालूम. अब इसमें तो एरर है. So now how do I? So I have data points here, and I'm drawing a graph P versus T. So now again, how do we estimate V versus S? So a crude method would be कि भाई हमने ये smooth graph draw किया और हमने कहा कि this is my P and this is my P. And I draw a secant line here. Secant is easy to draw between 2 points, very little error, right? So this is T1 and this is T2. Okay, are you getting this argument?
Yes, sir.
So I have P1 at T1 and P2 at T2. Now remember that P1 and P2 are also not the exact data points at T1 and T2. Once we have drawn the smooth curve, we have actually removed the error by drawing a smooth curve like this and finding out P1. So this is not exact data. This is already smoothened data, P1 and P2, by drawing the graph between data points which are slightly error prone. Not all of them are necessarily on the line, but we have drawn graphs and we have put data points. Now P1, so we know P1 at T1 and P2 at T2. So what is the velocity? Oh. These are the kind of things I thought would be part of your own self-study, but I'm sort of thinking. So obviously, what is the velocity? Delta P, which is P2 minus P1
by T. T2 minus
by
T1.
delta T, which is T2 minus T.
Yes, sir.
Perfectly fine. This is V, but this is V at what point? Obviously not at this point, and obviously not at this point. It is at some intermediate point where the tangent of this point is matching there. It is velocity, because you know somewhere in between some P star, and because you know that S naught is the starting point, therefore S naught, and therefore if you have at some point S star and P star, then by definition S star plus P star is equal to S naught, because product to consume nahi hoga. So from P star you can find out S star, which is nothing but S naught minus P star. ठीक है ना? याद रखिएगा, इसको ग्राम में मत करिएगा, मोल्स में करिएगा, क्योंकि ये S goes to P in molar concentrations है ना. ठीक है, ये ग्राम में material conservation of mass is not necessarily guaranteed, especially if you have some interesting byproduct being formed like Q. But molar concentrations में 1 mole of S gives 1 mole of P. ठीक है ना? If this is the basic equation. So, you know, if CO2 is released or oxygen is consumed, etc., in this reaction, or water, if it is a hydration reaction, water removal reaction, kinase reaction, phosphorylation reaction, etc., you may have some Q being added or subtracted. But molarity wise, 1 mole of S gives 1 mole of P. So you have to sort of find it out in terms of molarity. So please don't make silly errors. But so this is the balance. And therefore S star is S naught minus P star. So we can say that this velocity V corresponds to V at S star, where S star is nothing but S naught minus P star, where P star is somewhere in between P1 and P2. Is this argument clear?
Yes, sir.
हाँ, अब मैं आपसे कठिन सवाल पूछता हूँ कि what is this P star in terms of P1 and P2? I say it is P1 plus P2 by 2, arithmetic mean, है ना?
Yes, sir.
But why arithmetic mean? Why not geometric mean? Why not logarithmic mean? Which mean would be the best estimate of P star, given the form of this equation? This form of this equation emerges from my basic equation V is equal to V max S upon Km plus S.
S upon Km plus.
This is how the reaction is proceeding. इसका logarithmic आपने किया हुआ है.
Yes, sir.
ठीक है ना? इसका solution आपको पता है. अभी मैंने कल last class में बताया था.
Yes, sir. Km.
So now given this, the question really is, as it goes from P1 to P2, this is a reaction which is the integration of this equation.
Yes, sir.
So I can integrate this equation and let me call it as S1 and S2. Sorry, है ना? Instead of P1 and P2, we call it S1 and S2. That also the same equation, S2 minus S1 upon T2 minus T1, delta S हो जाएगा, but वो minus sign होगा, P1 minus P2, sorry, S1 minus S2 होगा, rather than P2 minus P1. ठीक है ना? It's just the negative sign. V is equal to minus ds by dt. है ना? So it's not very important, because this you know, stoichiometry is always not valid, right? And I'm saying that S star represents S1 plus S2 by 2. Now, is this a correct approach or is it an approximate? What is the exact S star that I should choose, which gives me the best estimate of this velocity at V is equal to V star? To answer this question, you have to integrate this and tell me what is the integrated time required and what is therefore the average velocity which corresponds to this integrated time. Are you getting this point?
Yes, sir.
So now let us do it. Or shall I give you the answer? And I will give you that the answer is the logarithmic mean.
Sir, we have integrated, so you can just explain it. In the previous class, we
Yeah.
have integrated it.
So you will discover that the best results are obtained when S star is the log. Do you know what logarithmic means, sir?
Yes, sir.
What does it tell me? What is the logarithmic mean of S star and S1 and S2? What is the logarithmic mean of S1 and S2? बताइए क्या होता है? S star, which I call as logarithmic mean, is equal to S1 और S2 का क्या होता है ये? और P1 और P2 का? P2 minus P1 upon ln P2 by P1. I hope you know this.
Yes, sir.
है ना? ये पढ़ा हुआ आपने? हेलो, याद नहीं आ रहा है?
याद सर पढ़ा हुआ है, लेकिन याद नहीं।
आप मुझे, मैं आपसे कठिन सवाल पूछूं, क्या बड़ा होता है, अरिथमेटिक मीन, ज्योमेट्रिक मीन या लॉगरिथमिक मीन? दो नंबर हैं आपको मैंने दे दिया। ओह, आप लोग भाई बड़ा परेशान कर रहे हैं हमें। अरे इनका ऑर्डर क्या है, थोड़ा जाके सोचिएगा। They all approach each other if P1 approaches P2, right? Obviously, because when they're close by. But when they're far away, the arithmetic mean, मतलब 10 और 20 का arithmetic mean क्या होगा? 15. Geometric mean क्या होगा? 20 into 10, 300 का अंडर रूट।
Yes, sir.
है ना? और logarithmic mean होगा 20 minus 10 upon ln2.
ln2, yes, sir.
तो कौन सा बड़ा है कौन सा छोटा, अब आप थोड़ा सोच लीजिए, मैं अब नहीं करने वाला हूँ आपके लिए ये सब काम, है ना? आप लोग बच्चे नहीं हैं।
Yes, sir.
So why is it the logarithmic mean is the question. Now let us do that. Now tell me why should it be the logarithmic mean. Now let us derive the fact that the best estimate of V is to be at the logarithmic mean of the 2 points where you join the tangent. You see, you're getting the point, right? I have joined 2 points, sorry, I have joined this point and this point at S1 and S2 or P1 and P2 and at time T1 and T2 and found out the velocity, which is delta S upon delta T or delta P upon delta, which is minus delta P upon delta T. But, and so I know the velocity. This velocity measurement using the second method. We have done a chord. We have drawn a chord rather than a tangent is always more accurate. I assume you understand that graphically. The chord is much more easy to draw, but the chord represents is the equivalent of a tangent at some midpoint by Rolle's theorem, right? So equivalent of the tangent. I hope you remember the mean value theorem in maths. याद है? बहुत पहले पढ़ाया गया होगा, नहीं? मीन वैल्यू थ्योरम याद नहीं है? याद आ रहा है आप लोगों को? मीन वैल्यू थ्योरम नहीं पढ़ा होगा आपने, थोड़ा याद करिए भाई। ये बहुत प्रॉब्लमेटिक है। ऑफ कोर्स वी आर नॉट इंटरेस्टेड इन मीन वैल्यू थ्योरम, बट आई एम जस्ट सॉर्ट ऑफ सेइंग, हाँ। So this slope here, the tangent of some point here in between S1 and S2 will be equal to the slope of the chord. That is what it says, equal to the slope of this chord between the 2 points, right? If the function is continuous. Continuity का equation है, theorem है ना? So let us forget this for the time being. I hope you remember your. So now the point is, which point should I choose so that it is the best answer for this question? Is this. Now, अरे इसका सॉल्यूशन क्या है? ds by dt के टर्म्स में करते हैं। चलिए s के टर्म्स में करते हैं, है ना? ds by dt is equal to, can you tell me the solution or shall I do it all over again?
Sir, km ln s by s naught by.
बहुत सही बात, चलिए बताइए। ओहो, हाँ क्या था ये? km
ln s by s naught.
s by s naught नहीं होगा, अब ये s1 और s2 होगा, ठीक है ना? ये 2 पॉइंट्स के बीच में हम कर रहे हैं, ठीक है ना?
Yes, sir.
हाँ,
Divided by T whole. Yes, sir.
होल थिंग डिवाइडेड बाय टी करिए,
Yes, sir.
टी को राइट साइड में रखेंगे,
Plus
S2 माइनस S1, S1 माइनस S2,
S2 minus
दोनों
S1.
को वो S1 माइनस S2 कर दिया और मैंने इधर प्लस करके VMT कर दिया।
Yes, sir. Yes, sir.
ठीक है ना?
Yes, sir.
ठीक है,
Yes, sir.
अब दिस इज द सॉल्यूशन टू दिस इक्वेशन
Yes, sir.
नाउ, एंड दिस इज T2 माइनस T1। ठीक है,
Yes, sir.
अब मुझे बताइए कि हम इसका स्लोप निकाल रहे हैं, सो व्हाट एम आई टेकिंग द स्लोप ऑफ, व्हाट इज द स्लोप इक्वल टू, दिख रहा है आपको सामने, ये P है, ये S है, ये S मतलब P, सॉरी मतलब आप समझ रहे मेरी बात, मतलब S जो है वो ऐसे होगा और ऐसा लाइन होगा, है ना, ये इसका रिवर्स है मतलब, है ना, तो ये स्लोप क्या है, इनवर्स ऑफ S, दिस इज डेल्टा S अपॉन डेल्टा T।
Yes, sir.
ठीक है ना, ये कॉर्ड है, सो दिस इज दिस डिवाइडेड बाय दिस। ठीक है
Yes, sir.
भाई, आपको डिराइव करना है, मैं नहीं डिराइव करूंगा, आई वांट यू टू डिराइव इट, सो अरे ओह, so this is delta, this is S2 minus S1 or S1 minus S2, sorry, oh, this is S2 S1 minus S2 divided by माइनस हो जाएगा T2 माइनस T1, चलिए ठीक है, जो भी है मतलब T2 माइनस T1, है ना, बिकॉज वो नेगेटिव होता है अदरवाइज, है ना, ठीक है, सो नाउ दिस इज द स्लोप ऑफ दिस कॉर्ड, this is the slope of this chord, and I want you to find out the velocity, the slope here, which is the velocity Vm S upon Km plus S, at what S star, at some S star between S1 and S2, which corresponds to this number. Are you getting this question?
Yes, sir.
So tell me, how will you approach it now? So I have something called V, I have something called V, sorry, I have something called V, and we have to do some approximations here, which is equal to Vm S star upon Km plus S star. ठीक है?
Yes, sir.
And I have this equation where I have this as the slope, S1 minus S2 T1 minus T2 Vm. Now can you tell me what is S1 minus S2 upon Vm minus Vm T2 minus T1? सिंपली इसको डिवाइड कर दीजिए, दोनों को डिवाइड कर दीजिए, मतलब इसको जस्ट डिवाइड कर दीजिए, so this here, this expression here, divide this whole expression by T1 minus T2 minus T1, this, take this whole equation and divide by T2 minus T1, what do you get? Km
ln
ln S1 by S2 upon T2 minus T1, right?
Yes, sir.
Plus
S1
minus S2 upon T2 minus T1, which is the slope.
Yes, sir. Which slope?
I will call it slope, or we should call it some m.
Yes, sir.
ठीक है ना? Plus m is equal to Vm.
Vm. Yes, sir.
ठीक है ना?
Yes, sir.
तो अब आप थोड़ा सा मुझे बताएंगे, अब आपको समझ में आ रहा है कि नहीं? अभी भी नहीं समझ में आ रहा है मैं क्या कर रहा हूं? These are, I would have put it in an exam. Thank God I did not put it in the end semester exam. बताइए क्या होगा? These are the kind of questions that we used to get. So we have Km ln S2 by S1 upon delta T, right?
Yes, sir. Yes, and
Plus M is equal to Vm.
yes, sir.
Okay. And now tell me what is delta T? Look at this expression here and tell me what is delta T? Delta T is Km ln S2 by S1. Okay.
Yes, sir.
Plus S1 minus S2 upon Vm. Right? That's also another way to look at it.
Yes, sir.
But really, I want you to get this expression here. So what is this? See, I do not know how to sort of put it simply. This is another way to put it, but let me sort of leave this out and now I put this, I multiplied both sides by S. Okay. I multiply both sides by some S star here, right? I'm running out of time and think about this. I multiply this by S star. Okay.
Yes, sir.
Some S star, and I want you to think about, I want you to match. Now I'm multiplied by S star upon Km plus S star. Okay, let me do this like this. Or let me do it, I mean, because I've told you the answer, ये जो थोड़ा tedious हो जाएगा. I am telling you that S star is the logarithmic mean. So I am saying, what is the V? Now tell me what is the V at S is equal to S star? What is the V at S is equal to S star? Vm S star. What is S star? Just now I said ln S2 by S1 upon S2 minus S1.
Yes, sir.
ठीक है? Yes, sir. Upon Km plus ln S2 by S1 upon S2 minus S1. This is V. And what I want you to do is to say that this is equal to M. Is it or is it not true given this equation? इसको आप भूल जाइए.
Yes, sir.
Yes, sir. Are you getting the question now? Are you following this argument?
Yes, sir.
The problem? Yes, sir. And given this equation and this equation, these are the same equations. From this equation, can you derive this expression? Where M is nothing but S2 minus S1 minus S2 upon delta T. ठीक है ना? इसको डेल्टा टी को भी M के टर्म्स में लिखिए जैसे मैंने अभी लिखा था. है ना? डेल्टा टी को भी M के टर्म्स में लिख सकते हैं आप बाकी के टर्म्स में. So delta T, as I told you, is ये क्या हो गया? Whiteboard.
Whiteboard.
Can you all of you see this? Both
Yes,
of you
sir.
see this?
Yes, sir.
So आप डेल्टा टी तो मैंने अभी आपको बताया क्या है. So delta T is nothing but Km ln S1 by S2. ये कभी S1 लिखता हूँ S2 लिखता हूँ प्लस S1 minus S2
upon V.
upon Vmax.
Yes, sir.
मैं बहुत इरिटेट हो गया उस कंप्यूटर से. Upon Vm. So this is my expression for this, and this is my expression for this, and I want you to go back and forget this part, huh? And I want you to prove that therefore approximately this expression is better rather than this is what I'm trying to ask you to derive. Can you derive this?
Yes, sir.
Yes, sir. चलिए ठीक है, मैं इसको यहाँ पे छोड़ता हूँ, है ना? And I will stop here. So these are some of the interesting issues of how we work with deriving kinetic constants from simple experiments. Notice that once we have this derivation, the actual problem becomes rather simple, which is, draw a graph of S versus T or P versus T, choose 2 points, find out the secant slope, and draw the chord between 2 points, and then using these 2 points, you can choose that is the velocity at that 2 points. So you can actually now have a much simpler situation where you can now choose groups of points T versus P or S, whatever is plotted there, not P by S. S and P are very similar because S naught is equal to P plus S. Okay, and so 0, 1, 2, 3, 4, and you have these data points, and you can draw a smooth curve through this P versus T, and then choose points at alternative intervals and draw chords. And at each chord, the ln mean of between all these points is the velocity which these values represent. And so you have a V versus S plot, which can then be allowed to make a proper determination of Vmax and Km. Are you following this argument?
Yes, sir.
मैं एक बात और घुसा दूं, चलिए मान लीजिए कि यहां कॉम्पिटिटिव इनहिबिशन है. अब ये प्रॉब्लम हो गया, पी से कॉम्पिटिटिव इनहिबिशन हो रहा है. अनकॉम्पिटिटिव के लिए सॉल्वेबल नहीं है, लेकिन कॉम्पिटिटिव के लिए ये एक्चुअली सॉल्वेबल है बाय लुकिंग एट स्लोप्स एंड देन प्लॉटिंग इट अगेंस्ट पी. I don't know whether I'll be able to do this, but these are some of the more interesting complex graphical solutions. Suppose you have competitive inhibition, then again you can do the same method, but now you have to take slope from 0 to 20, say 10% P, 20% P, 10% P, 20% P, 30% P, 40% P, and so on and so forth. Then you take join 0 and 10, join 0 and 20, join 0 and 30, join 0 and 40, and then you can actually, well, and I think I'm taking too much of a shortcut. We don't have time. Think about this question. Then you can actually solve for competitive inhibition at different concentrations of P, if P is a competitive inhibitor. So that's a more complex problem. I'm not going to get into it. I'm just sort of going to mention it, that it is also solvable for competitive inhibition with a little bit of more algebra. Okay?
Yes, sir.
Okay. So there is this book. I think there should be carrying the answers, the Hans book. But what I was trying to demonstrate to you was a simple case of the chord, and what is the slope of the chord is easy enough to find out, and what is the substrate concentration which would have a tangent equal to the slope of the chord. That substrate concentration is the logarithmic mean of S1 and S2. That is a simple argument that I was trying to make. Is this all right?
Yes, sir.
That point you have understood? Yeah, thank you.
Sir,
Shall we stop here? Yeah, go ahead.
Sir, I joined the course late, so sir, I just have done the practical. So sir, can I submit the assignments now, sir, please?
Which practical assignments?
Yes, sir. I joined in February, sir. Actually, I'm.
What were you doing?
Sir, actually, I'm an old student, so sir, I joined the courses in February only.
तो तब उसके बाद से आपने प्रैक्टिकल एक भी नहीं जमा किया है?
No, sir. Only first 3.
You have submitted first 3.
I have not submitted first three. Others I have submitted.
Okay. You have not submitted first three. Later on, you have submitted. Okay, you submit first three now. Okay, do it. Send
Okay,
it to
sir.
me by email. Okay.
Okay, sir. Thank you, sir.
Okay. Shall we stop here?
Yes, sir.